All right, here we're really looking at section 5.6, and the sheet that you're going to need today looks a lot like this one. So we go ahead and fold it first, and take a minute to write these three things on here. And yes, they kind of need to go in this order because our graph really needs to go in the middle, and then we'll get started. So we always want to start with our learning targets. So in my notebook, you'll see here's our learning targets, and down here at the very bottom, this is our last learning target of our whole chapter. So I can find and verify inverses of functions both algebraically and graphically. That's what we're really going to be doing. So on your next clean page in your notebook where all of your information is going, here's where I'm going to go with this one. So this is going to be section 5.6, and we're talking about inverses of functions. Okay, so that's where this is going to go, because I have a couple of little things that we need to put on the side of our notes, not just this piece of paper, but this is really where we're going to start. So these are three different ways we can find inverse functions. Okay, so the first is to find the inverse from a table or from ordered pairs. So how we do that, the thing that we do in order to do that is we switch the x and y. So for example, if we have this ordered pair, right, and in this table I have some x values of 1, 2, 3, 4, and y values of 5, 6, 7, 8, the inverse function then, I would just switch my x's and my y's. So my x's become my y's and my y's become my x's. So this would be 5, 1, 6, 2, 7, 3, and 8, 4. So this can also be done as this table, but also in ordered pairs. So if I have, for example, 0, 2 as one point, I have 4, 9 as my other point, then the inverse of that would be 2, 0, and 9, 4. So you see, when I just have a table or ordered pairs of my points, it's really easy to find the inverse because I just switch my x and my y. Okay, so now let's look at what this looks like from a graph. Okay, so again, I switch my x and my y. That's the biggest things. I switch my x and y. Now we're just looking at it instead of from a table, we've got our graph. So here's another little thing about the graph. So the graph of the inverse is always, and I'm going to underline that because that's kind of an important piece, a reflection over across the line y equals x. So if you look at this line that we're reflecting it across, that, and we'll just do a quick little, right? So that's the line that I'm dealing with. Okay, so I'm going to go ahead and draw that. So my y-intercept is 0 because I don't have a b value, and my slope is 1. So it's just this line right here is the line that I'm going to be reflecting my inverse over. So even if I have any kind of function, here I'm just going to do some points. Okay, so this is going to be what we are going to be reflecting and finding the inverse of. So we just have some points here. So to find the inverse of this, again, I just switch my x and my y values. Okay, so here, this top point was at 0, 1, 2, 3, 4, 5. So its new point, now that I find my inverse, is at 5, 0. So it will go here. This point was at 3, 1, so it now goes to 1, 3. And you'll see how it's just a reflection. I'm crossing it over this line of y equals x. Okay, so this point of -1, -1, it just, it's cool because some of these things don't actually change super well. So this is a 1, -1, so now it comes -1, 1, and you'll see again it just crosses this line. And this last point was at -3, -1, so it goes to -1, -3. And again, we can always look, and does it look like it's crossed over that line? So even if I have an actual function, so if I was to have something that looked like this, and we'll get into this, its inverse, I can reflect it across this line, would then kind of look like this. Okay, so now we've got a couple of examples of what inverses look like on a graph. Okay, so now we're going to look at an equation. So in my equation, what I do is I replace x with y. Again, I switch my x and y. and then I solve for y. Okay, so for example, if I have y equals x minus 4, to find the inverse, I switch my x and y. Literally all I've done is switched them. So now I'm going to solve for my y. So then I add 4 to both sides. So I have x plus 4 equals y. This can be done with larger functions as well. So here's another one we're going to look at. So here we have 2x minus 3y equals 4. So to find my inverse, I switch my x and my y. So I now have 2y minus 3x equals 4. So then again I can just solve for my y. So to do that I add my 3x. So I have 2y equals 4 plus 3x, and divide by 2. So y equals 2 plus 3 over 2x. This would be the inverse function, just like this is my inverse. Okay? So hopefully you'll see that no matter how we're given our function, or even just our relation, we can take it and switch our x's and y's and we have our inverse. So now this kind of needs to go in here. So we're going to go ahead and glue this down, and then we've got one little like star piece of information that we must have, just some notation kind of information. So there we go. So there's our inverses in 3 different ways. And here we just kind of looked at lines and pairs of points. These can be in radicals, this can be rationals, this can be any kind of function. We can follow these same steps to get there. Okay? So the other key piece of information that we have to have is that if, and that's a big if, the inverse of a function is also a function, it is denoted as f minus 1 of x. Right? Because if we have our function notation, we've got f of x. This tells me that the inverse is also a function. That little -1 tells me that, yep, that's the inverse. Okay? So this is kind of just a